So our next mechanism is called edge scissors. Just like its name, player can use the edge of the walls to cut the object. So we have a working version of it. So let me show you how it's working. So player pick up an object, then he find a good angle, then he click again to release the object. You can see the object is being cut, and the two different part of object is being mapped to different surface. So it gives the illusion that the ball is like the edge is cutting the ball. So let me show you the detail. You can see the ball object is in the cuttable layer, so only the cuttable object can be cut open. So the wall is also have its own layer. It's called a cutter. If I run the game, the cutter n is the game is creating two child object for cutter n. So it's a pivot. So the inside that two child object. So currently what I select is not exist before I running the game. So let me show you its mesh later. Maybe show you mesh render. Also here is like other wall. Other wall is also have its own plan being created. So if we walk around in the scene right now, or let me show you, you can see there's from the two edge of the two wall, there is actually four face that is tracking the user player. So I think a lot of you guys already understand this. Like when I hit the click, the ball will be cut through the using those edge. They are acting like a knife, right? So if I can find the ball, let me find it. So if I pick up, then you see it's like here. So player can, if I hit a click right now, the ball will not be cut because I write a code that it doesn't detect the ball is intersecting any four of the edges. So if I hit here, it's actually, you can from the top you can see it's the left edge of the wall behind the first wall. So the game, my code is already also detecting that. So the code is like the four of the edge, only this edge, the right side of the front wall will be cutting the object. It's able to cut the object. So then it's just make its illusion. And the code is also can recognize left wall if we are in the weird angle, for example like this angle. So here you see it's from the top, you can see we can cut it from here also. So the code can recognize which wall is near the player, which wall is farther. So yeah, that's basically it. So we're currently still working on that code to fix the errors. So one classic error will be like in the graph. So I just draw the green, there is one green wall at the front, green wall at the back. Here is a ball. This is a player with his camera. So if I draw the center line, like if I shoot out a ray from the camera, it's hitting the second ball, right? It's not a player is not facing to the first wall. So the thing is currently, what the game will know is the player is facing the second wall. But the issue is that doesn't matter. That doesn't help a lot. We need the information from the first wall, because if you think about that, the second wall have two edges. It's facing to the camera, but the thing is neither of them go through the object. So when what is important is the first wall. The first wall is going to have its right edge will cut the object even we facing to the second wall. But the thing is, there is no efficient way to get the first wall to the script. Like a script don't know it's a first wall, or there is a other wall, or there is other wall after the second wall, or there's even more wall like in the front. So the script is confusing. Like it's very not efficient to tell the script which one of those wall is correct. So yeah, so because they all have edge, so this I will loop through every edge in every frame. So it's not efficient. So current situation is actually we still using the ray shootout from the camera, but we are extending the collider for the first wall. I mean for every wall. It doesn't cost too much, right? So for the every wall, so there is an invisible collider. When camera is shooting out a ray, it will hit the collider. It will know, oh, this wall is going to cut the object. Then even he hit the right side of the cutting edge, they will still get the edge. At least we get the game object of the cutting, real cutting wall. So, but other problem will come, like how wide it should be. But like it's actually how wide it should be is depends on the radius of the object. So if we want to make a perfect mechanism, which we are not going to be, I will tell you why later. So we will, like, when player pick up like elephant, at that moment every wall, like we will measure the radius of the object. So it's very hard, it's easy to sound, but which axis or which angle, what radius. So just assume if we have a radius, okay, this is elephant is very far, so then I probably can facing this way, so it's very big. So then we're going to extend the collector of the every wall even farther, right? So that could be a solution, but that also brings other problem. If some wall is close by, then we make it longer, so it we will hit other wall first. So it's just like in this situation, I think it will be the problem about level design. What we're going to do is we're going to just extend little bit of the each wall. Then the object player can hold is not going to very big. It will be inside the range. I think it's normal, like every game have their own design and choice. For example, Legend of Zelda Breath of the Wild don't have an infinite world like how Minecraft have. But that is not necessarily the downside of Zelda. So it's the same for us. In the given limited time during this course, we're going to make a puzzle game. The number of the objects that helps the player to progress during the game is limited, hence the size of the object. So this is a proof of concept of the edge scissor.